Okay, now as I promised, let's go through and calculate this out as just dimensions on a blob. Let me add a new layer for the calculations. So here I have got a blob of some description. I've got a pin there, I've got a pin there, I've got a pin there. There is 100 kilonewtons pushing there. Kilonewtons, sorry, that's a fiddly pen at 45 degrees. I do know that that vertical distance is 1.732. I do know that this distance is 3 meters and that distance is 3 meters. Go backwards and have a look at our page. So let's now have a quick look. See, that's at 45 degrees. So if that's 3 meters and that height there is 1.732, that means that that distance in there is 1.732. This distance in here is 3, take away 1.732 is 1.268 meters. So there's our horizontal distances figured out. Line here travelling down at 45 degrees. I need to get this distance here, I need to get that distance there if I'm going to not resolve that 100 kilonewton into components. To get that distance there, I know that that distance from there to there is 4.732 meters, just adding them both up, which means then that this here, I do know that D on 4.732 equals sine 45, D equals 4.732 times sine 45's 0.7071 equals 3.346 meters. Okay, so now I've got that distance. Let's go moments about the left hand side. I've got here moments going that way equal moments going that way. Moments going clockwise is 100 times 3.346. This one here is going anti-clockwise, equals 6 times 6. Reaction right, vertical equals 6 times, asleep, equals, that's 3.346 equals 6 equals 334.6 divided by 6 equals 55.75 or 77. No calculator necessary for that one. Okay. So I've got the reaction right vertical. Reaction right is 55.77. So we can draw that in, or I can check the answers again. 55.76. Yep, perfect. Okay, to get the left hand side now, using the same logic, there's a triangle that's 1.268. That's a 45, 45. So I'm going to call that distance E. E equals, I'm just going to use the same logic, 1.268 sine 45 equals 0.896. Now let's take moments about the left hand side. Moments about the left hand side. Moments going that way equal moments going that way. Moments going clockwise that's pushing anti-clockwise. So I've just got the vertical moments, reaction left vertical times 6 equals 0.896 times 100. Reaction left vertical equals 89.6 divided by 6 equals just a bit shy of 15. 14.93 kilonewtons. Now I also know the reaction left horizontal equals 70.71 going that way kilonewtons, because this 100 kilonewtons at 45 degrees results into 70.71 both ways. I've already allowed for the verticals, but that horizontal, let's pick a colour that stands out against the bricks. 70.71. So if that's what that 100 kilonewtons is doing, pushing that to the right, then reaction left's got to be there. The answers, same. 70.71, 14.93, 55.76. There you go. That's essentially why I want you to do it graphical.